Good afternoon, everyone. Am I audible?
Yes, sir.
Okay. So in the last class, we have discussed different issues and challenges of wireless sensor network. Any confusion? Anyone have any query? Okay. So today, so basically in wireless ad hoc network, we have already discussed different categories of protocols. One is called MAC layer protocol. The another one is called routing layer or routing protocols. But in case of wireless sensor network, we are not going to discuss any MAC layer protocol because in sensor network, most of the MAC layer protocols we can introduce or we can incorporate as per the requirements. But the only difference in sensor network is the routing capability or the routing mechanism. So that's why in sensor network, a special importance is given to the routing protocols. So, so basically, what is routing? We have already discussed, and we already know that routing is nothing but finding the best possible path from source to destination for delivery of packets. That means till now we have discussed different types of networks. Basically, in previous semester, we have discussed the simple wired network or simply a computer network. There also we have discussed what is routing. Then after that, we have discussed wireless ad hoc network. There also we have discussed routing, and now we are going to discuss routing protocols for wireless sensor network. That means the basic mechanism or basic necessity of routing protocol is simply finding the best possible route. But when we discuss the routing protocols, we will find that for each and every network, although the goal is same for all routing protocols, but we find that the mechanisms or how they are going to perform the routing is different. In this sensor network, the routing protocols or routing mechanisms should be capable of handle the sensor node. So accordingly, we have different types of routing, different categories of routing. Under each category, we have different routing mechanisms for different types of sensor network or the networks which can be created in different environment using some sensors. So right, routing protocols for wireless sensor network. Oh, I forgot. There are two left. Okay,
Excuse me, sir.
yes. Now I remember. Now someone. Yes. So let me discuss something about routing protocol. Then after that, I will take the presentation of the remaining two. Okay. Since only
Okay,
two students are remaining, so it will require hardly 15 to 20 minutes. So let's discuss something about routing protocol. So right, routing protocols for wireless sensor network. Right? Wireless sensor network consists of wireless sensor network consists of wireless sensor network consists of different types of protocols, different types of protocols different types of protocols
স্যার
and
ৰিপিট কৰিব
algorithms.
লাগে নেটৱৰ্কটো মানে স্যাৰ আপ এণ্ড ডাউন কৰি আছে আমাৰ ইয়াত
Okay, I'll start from the beginning. Wireless sensor network or WSN, wireless sensor network or WSN consists of different types of protocols and algorithms. Consist of different protocols and algorithms with self-organizing capabilities. Full stop. After that, routing protocols are responsible for routing protocols are responsible for responsible for establishing and establishing and sending data establishing and sending data from source to destination from source to destination by using multiple sensor nodes. Okay, full stop. After full stop, all the routing protocols, after full stop, all the routing protocols in WSN, in WSN, in WSN have a common objective have a common objective of efficiently utilizing the resources of sensor nodes to extend the lifetime of the network.
Sir, last line to akabar repeat koribo naki?
Okay. All routing protocols in WSN have a common objective of efficiently utilizing the resources of sensor nodes to extend the lifetime of the network. Okay. Okay, let's start the presentation now, because otherwise it will end before time. I will discuss the next topic in the next class. Let's start the presentation. Who is going to give the presentation? I think Divya and Kaushik.
And Asidar also, sir.
Yes, three.
And Momocha, sir. Into he absent as a second.
Okay. You start. The maximum time is 10 minutes. Okay, maximum, because only 30 minutes left, I think. Kaushik, you start. Kaushik, you are not audible. Your voice is too low.
Sir, am I audible now?
Yes, but your voice is too low. Unable to understand it properly what you are saying. Maybe some issue maybe with your headphone.
Sir, is it now okay?
Okay, okay, you continue. Still low, but it's okay.
Good afternoon, everyone. Today the topic of my presentation is signal stability based adaptive routing protocol. The content of my presentations are introduction, working principle, advantages, and the disadvantages. The introduction: signal stability based adaptive routing selects the route based on the signal strength between the nodes or the node's location stability. Means from this definition we can understand that the route is selected by their strength of their signal. It comprises two protocols. One is dynamic routing protocol, other is the static routing protocol. In the dynamic routing protocol, it maintains the signal strength of neighboring nodes by periodic beacons among neighbors. It means through some transmitting transmitters, it will transmit the signals one to other, and signal strength is recorded as a strong or weak channel. In the static routing protocol, it processes the route sir. The working principle. In here, the query of are forwarded if they are received over a strong channel and it has never been processed before. So in the picture we can see from the source the strong channels which are going to the destination, and the other there are some weak channel. They can't be sent in the destination because they are very weak to send, and our in our SSA we follow the rule where the channels are very strong, and if there is preferred field on the head, in the there are the advantages. They have a tendency to leave as compared to the shortest cut route selection. Like yes, one disadvantage is it can't send it's follow only the some delay in the routing system. Another disadvantages of SSA is no attempt is made to repair routes at the point where the link failure occurs. This may introduce the extra delay since the source must be notified of the broken like before another can be found. That's all for now, sir. Thank you.
Okay, thank you, Kaushik. Uh, So my question is that just mention two major
Sorry,
situations
sir, I can't.
where uh, simply mention
Sir.
one or two situations where we can use this particular protocol. That means in which situation is suitable one.
Next situation. Hello, sir.
Yes, yes.
Sir. Hello.
Yes.
Sir, can you repeat the question, sir?
Kaushik, are you there?
Hello. Sir.
Yes, yes.
Sir, can you repeat the question?
So in which situation this protocol is most preferable one? Can you answer it?
Sir, in which situation? No, sir.
Okay. So whether this routing protocol follow multi-hop, that means hop by hop routing, or it is based on source routing, source-based routing.
It is very source to destination routing.
Every routing is a source to destination routing, but still
Sir,
there are some category.
yes, sir. In this protocol, it will choose the route by the strongest network we have on the node to node.
Okay, okay. Thank you. Next,
Thank you, sir.
who is next?
Sir, I will proceed.
Okay.
Sir, is it visible?
Yes.
Yes. The topic of my presentation is associativity-based routing protocol. The first thing, the introduction, it is on-demand routing protocol, or we can say reactive protocol. And the characteristics of these protocols is that they determine route only when demanded. And here, ABR looks for stability in the route. So therefore, it searches for stable and short route to destination. Only links that have been stable for some minimum durations are utilized. And terms like associativity tags, beacons, these things are used for selecting the routes. And node increments the associativity tick that are root root is selected based on the degree of stability associated with mobile nodes. That means for selection of root, it depends on the degree of association stability. Here, each node generates signifies its existence. Received by neighboring nodes, the beacon caused their associativity tables to be updated. And here that means the more the associativity ticks, the more stable the node will be. Now, what happens in the root discovery? The root discovery is accomplished by broadcast query reply cycle. And for root deletion, in that when a discovered root is no longer desired, the source node initiates a root delete broadcast so that it deletes all the update of the root. Now I will talk about the process. The source node forwards in this. The source node forwards the root request packet, and the root request packet, it carries the path it traverses and the beacon count of the corresponding node in the path. In the first, when the root request reaches the destination, what happens? In that, over there, means over there, it will means the destination will wait for more root requests, as there will be more than one root request for means there will be more than one routes for the destination. That's why it will wait. And then after that, after getting the route request, it will select the path that has the maximum number of stable links. And then after that, the destination will send a one reply. And then it will validate that path. So like this. There are so many ways we can go from 4 means here we have taken 4 as the source and 14 as a destination, and it's selected 1. And now what happens if the link breaks? If the link is broken, it invokes RRC, that is root reconstruction phase. And here the first what it will do, the node closer to the resource means source, it will initiate one broadcast message, that is it will call LQ query, that is local query with TTL. TTL is used for means to prevent loops. And at first, if it will not be able to repair the the root, then from the destination side it will try to repair. From there also, if it will not repair, then it will send the message to the source that the root cannot be repaired. That's all. Thank you.
Thank you, Divya. So what is in your presentation you have mentioned that root discovery.
Yes, sir.
So what is root discovery, and how much important to this operation in a network?
So root discovery. So root
Yes.
discovery is like searching for the path from source to destination. So from where we can get the shortest and stable path for our data transmission. That is the root discovery.
And why we need to perform this operation?
Is important because we can this is the only means the first step to transmit our data. Like for data transmission, this is our first step that we have to do. And so for our better route, we have this first phase.
Okay, thank you.
Thank you, sir.
Next, and the Daswidar, you have 5 minutes.
Okay, sir. Sir, is it visible?
Yes.
Okay. Good afternoon, sir. My name is Dasudokshir, and the topic for today's presentation is about dynamic source routing protocol, that is DSR routing. Today, I will cover the introduction part, how DSR protocol works, and some of the advantages and disadvantages. What is dynamic source routing protocol? It is a simple and efficient routing protocol designed specifically for use in multi-hub wireless ad hoc networks of mobile nodes. DSR stands for Dynamic Source Routing. It is a self-maintenance routing protocol for wireless network. In DSR, each source it will determines the route to be used in transmitting its packet to selected destination. Here there are two main mechanisms in DSR, that is the route discovery and the route maintenance. So now we will see how DSR protocol works in step by step. This is my node, and my main objective here is to send data from source to destination. Here S is the source node and D is the destination node. Initially, node S don't know the route to destination. So now S have to find the route to reach the node D, and this searching, we call it as route discovery. So our phase one is route discovery, as I mentioned earlier. Now, node S will ask its neighbor node if they might know about the node D. So this source will send a request packets to its neighbor node, and the format is RREQ packet, which will contain the unique ID, the list of node that is initially empty, lastly the source and the destination. The first diagram shows the request packet of sources node S. Now this packet resource will send to its neighbor node, as you can see in the second diagram. This source will send to its neighbor, that is C, B, and A. Now, in the first diagram, node C will also check whether the destination node is there or not. Since node C, this node C also don't know the destination node. So C will insert the ID and broadcast it again. As you can see in the second diagram, this C will send its ID to its neighbor node and it will broadcast. Now a node receiving the multiple broadcast packet, it will newly arrived broadcast packet will get cancelled. As you can see in the first and the second diagram, this node C and S, it will get cancelled. Now the same thing, it will repeat again in the node B. This node B will insert the ID and broadcast to its neighbor node, as you can see in the first diagram. But in the second diagram, this node C and S will get cancelled and broadcast packet it will because it is received from node B, since they have already received a packet before. Then all these above node will get cancelled because it have received the multiple broadcast packet in the same node. So now we will take this node F, and this node F also will share its ID to its node B, F, and S, and then it will broadcast against to its neighbor. So the second diagram shows after the node F broadcasted. Now after the broadcasted of node F, finally the destination node is found, and the ID is 2BF, 2BFS, and D. Now to reach from this node D to this source, from destination to source, this D will reply a packet using this ID D, F, B, and S. This will be the second phase, that is RREP. In the given two diagram, it shows how this D send a packet to S to carry the data. So now S will send the data using this reply packet to node D. Now here, what if after sending this route to S node, the connection between F and D here is the second mechanism that came into, that is the route maintenance, which says that if any link broken information is broadcasted to make them update their cache route. So to fix all these, this route will get updated. The advantages: routes, it will discover only when they are needed, and this route maintenance overhead it will reduce, and also it will reduce the cost of the route discovery. The disadvantages is that the packet header size grows with route length due to source routing inefficiency, and this route request packet it will reach to all the nodes in the network, and it will also increase the contention if too many routes replies come back. Thank you.
Okay, thank you, the leader. So my first question is, DSR is a reactive or proactive protocol?
So DSR is a reactive protocol.
Reactive protocol. Okay. So in react, how they are going to the route info? We always we know that in reactive, when there is any requirement of node, then the protocols are try to establish a network. Yes.
Yes,
Then
sir.
my question is that how DSR or how reactive protocols are going to maintain the route info? How they are going to initiate and how they are going to maintain the route info?
How they're going to. So by using this cache memory.
By using the cache memory. Anything else? And there is a basic difference between DSR and the other reactive protocols. Do you know the difference? Although DSR is a reactive,
So low. Hello.
Yes, yes. I'm listening.
Sir, can't hear your question properly.
So that means although DSR is a reactive protocol, but still there is a difference between DSR and the other reactive protocols. Do you have any idea regarding this? Or do you know the difference, exact difference?
So I'm not aware of it.
You are not. So that means in the reactives, they simply used a root request message or a hello message to um, inform its neighbors about its existence. But in case of DSR, DSR does not use the hello packet. Okay, go through it.
Yes.
You'll find
Okay,
that.
okay
Okay,
sir.
okay
Okay,
then.
sir.
Okay, thank you everyone. It's a
Thank you, sir.
nice presentation for explaining the things. Okay, and one on how to prepare the slides. Okay,
Okay, sir.
so uh, give, give effort or improvise your way how you are present these things. I'm mentioning it to all of you. Okay, some of you are doing well, but still you need improvisation, and that's why how you are going to present these things, it is very important. So try to improve it. Okay, okay then. Thank you everyone. We'll continue in the next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.